Section 2.4 on quadratic equations. Now that we've mastered linear equations, linear means degree 1, we spent section 2.1, 2.2 and 2.3 on it. We are going to graduate and solve quadratic equations. Quadratic basically is just a fancy word, just like linear is a fancy word for degree 1. Quadratic is a fancy word for degree 2. So we're going to take a look at how to solve equations that are degree 2. It's still an equation, so still has an equality in it. That's what makes it an equation. Okay, so let's take a look at a general form of the quadratic equation. So the general form, I'll abbreviate quadratic equation as QE of the quadratic equation is you have ax squared plus bx plus c is equal to 0. So this is what a typical quadratic equation looks like. It's degree 2 and it's an equation, okay, where a, b, and c are just some real numbers, and a is not equal to 0. And that's important because if a is 0, then this term is no longer present and the equation becomes linear. So it's important that we know that a is not 0. That's what makes it quadratic, that term. Okay, so that's what a typical quadratic equation looks like. Since it's an equation, we obviously want to solve. We want to find a value of x for which the two sides are going to be the same. So let's go ahead and take a look at how to go about doing that. Okay, there are many different ways to solve quadratic equations. So let me write some of those methods down. This is B. Methods for solving quadratic equations. Okay, so there are many different ways to solve quadratic equations. Okay, so the first method is by factoring. We learned how to factor in the last chapter, so we're going to factor the left hand side of the quadratic equation and do that. So the first method is using factoring to solve a quadratic equation. And again, you know the shortcomings of the factoring method. Not every polynomial of degree 2 can be factored, so we run into issues with it. So we need other methods, obviously. So since not every polynomial of degree 2 can be factored, we do need to have some other ways to solve quadratic equations, and we'll talk about them. Second method is basically the square root theorem. The third method to solve a quadratic equation is completing the squares. The fourth method to solve a quadratic equation is actually the quadratic formula. And then the last method to solve an equation is, this is true, it's not really a quadratic equation, but we can make it into a quadratic equation is what we're really getting at here. Okay, so in this case we say it's almost quadratic. So the equation that's given to you is not quadratic, but it's almost quadratic. We can make it into one, and once we make it into a quadratic equation, then we can use any of these other methods to solve. Okay, so that's what we mean by that. And that might be something, if I have time, I'll do it in this section, or we might do it in a different section. But for now, let's go ahead and start with the first method, factoring. Okay, so let's do that. So if you recall, a couple things we quickly need to remember before we can do this problem by factoring. Okay, just quickly review like a sidebar. Recall: 1. Not every polynomial of degree 2 can be factored. Okay, And so that's something you should just remember. So how do you know when a polynomial can be factored? So to do that, let me say if you're given something like this, that's just something to remember. Given you have ax squared plus bx plus c, you have a polynomial of degree 2. This polynomial can be factored if the discriminant and the discriminant is given by this formula, d is equal to b squared minus 4ac, where a, b, and c are coming from the above equation, are the coefficients of x. If the discriminant is a perfect square, so if the discriminant is a perfect square, then we can factor that polynomial. Okay? So these are just two things to remember. We've done this before in the last chapter, but I just wanted to quickly review those so we can get started. Alright, so before we can learn to factor a polynomial by solve a quadratic equation by factoring, we need to learn something called the product theorem. So this is the product theorem. Theorem, again, is just a mathematical statement that has been proven rigorously, so now we can take it for granted, which states that if the product of two numbers a times b is equal to 0, where a and b are just some real numbers, if a product of two numbers is equal to 0, then either a is equal to 0 or b is equal to 0. And that makes sense, because if you multiply two numbers and the answer is 0, the only way you get 0 in multiplication is if one of the numbers is 0. Okay? So that's what we're going to use. And the reason for that is because, if you recall, what factoring lets you do is it basically lets you write something as a product. So it lets you write something as a product. And as soon as you write something as a product, we can use the product theorem then. So that's what the nice thing about factoring is. Okay. Now, before I go any further, I do want you to realize that not every polynomial can be factored, like I said. So there are other methods we do need for that reason. Okay. Alright, so let's take a look at ones that we can do. So here's an example. Let's start with something simple. You have x squared minus x is equal to 12. I want to solve this equation. This is an equation. Anytime you have a degree 2, a quadratic equation, you always want to have 0 on one side. You can see that from the general form of the quadratic equation. We always want 0 on one side. So let's move the 12 over to begin with. So we get x squared minus x minus 12 is equal to 0. So now the question is, can I factor this? I'm just going to do this once, but I won't do it again. Always do it on the side. Let's check to see if this can be factored. A is equal to 1, b is equal to minus 1, put parentheses since it's negative, and c is equal to negative 12. Again, put parentheses since c is negative. Let's calculate the discriminant. We're just checking to see if it can be factored. It can, but I'm just going to prove it to you. B squared minus 4ac is the discriminant. B, so you get negative 1 squared minus 4 times 1 times c. So we get negative 1 squared is minus 1 times 1 is minus 1, plus negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. So you get 49. And that's a perfect square because 7 times 7 is 49. So in this case, we know that this polynomial can be factored. So now that we know, again, let's just do it on the side. What do we want to do? I want to find two numbers. When I multiply, oops, you can just do it on the side here. When I multiply, I get the two numbers m and n. I get 1, there's a 1 here. 1 times negative 12 is negative 12. And when I add, we get minus 1, the b in the middle. And you just play with numbers in your head, or you can do it mathematically like I showed you in the previous chapter. So in this case, the numbers are what? M is negative 4 and n is 3. You can verify that. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So now that I found the two numbers, since the leading coefficient is 1, I can just break it down into x minus 4, x plus 3 is equal to 0. So now we can see we factored this. As soon as we factor this, we've written this as a product. So now that this product is 0, according to the product theorem, if the product is 0, then what can we say? Either A is 0 or B is 0. So in this case, what does this tell us? That either x minus 4 is 0 or x plus 3 is 0. One of these factors has to be 0. If this is a linear equation, we know how to solve. Move the 4 over, we get 4. Out here we get x is minus 3. So my solutions to this problem are what then? The solution to this problem are x is equal to 4 and negative 3. Now, I've shown you in the section 2.1 how to check your answers, right? We can quickly plug it in and check our answers. So let me just do that one more time here just to show you. If you want to check your answers, what's the first thing we do? We store the value of the variable 4 into the variable x, so we go store x. And in this case, we just want to calculate the left-hand side because we already know the right-hand side is 12. So let's do that. So we get x squared, so we get x squared minus x, that should be 12. Now we're going to store 3 into x, negative 3. So let's do the same thing. We get x squared minus x gives us 12. So you know both those answers work, so we got our solution. Since it's degree 2, we're usually looking for 2 solutions. Okay, so we got 2 solutions. Now, before I go any further, I really want you to make sure that you understand the product theorem. So I'm just going to erase this for a second. I have a lot of students in the past do stuff like this, and I just want to make sure that you guys don't make the same mistakes. What they will do is they'll realize, oh, I can factor this, so they'll take an x out. I get x minus 1 is equal to 12. And then they say this product is 12, so they say x is equal to 12 and x minus 1 is equal to 12. So you get x is equal to 12 plus 1, you get x is equal to 13. And they'll do it this way. And you can clearly see this is the wrong way to do this. Just because a product is 12 doesn't mean that this number has to be 12 and this number has to be 12. Because if that is the case, then you'll get 12 times 12, which is what? 144. If both of these numbers are 12, then you should actually get 144, not 12. So you cannot use a product theorem like this. You can only use a product theorem if the right-hand side is 0. That's why we always try to move everything to one side. Let's take a look at another example, and then we'll move on to the second method. So let's say if I have 3x squared is equal to 2x plus 8. And once again, like I said, we would need to check to see whether we can factor this or no. But let's I'm sorry, I'm getting ahead of myself. Let's solve this for x first. It's degree 2, equality. Move everything to one side, so we get 3x squared minus 2x minus 8 is equal to 0. Okay. Now, how do I solve this? How do I factor this? Right now we're just learning to solve by factoring. The first thing I would do is check to make sure this can be factored by doing the discriminant business like I did here. Unless you already know it can be factored, I know this can be factored. So let's see how we do this. I want two numbers. When I multiply, we're going to use the AC method that we talked about in the last chapter. Okay. When I multiply, I get 3 times negative 8 is negative 24. And when we add, we get negative 2. And you can clearly see those two numbers are what? M is equal to negative 6 and N is equal to 4, because negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. Now, because there's a leading coefficient here, we have to write it this way. We get 3x divided by 3 is equal to 0. Remember this, we're just using the AC method. And if you feel more comfortable, I usually advise students to just do this on the side. So let's just do this on the side. It's better to get into good math habits. It'll stick with you for a longer time if you develop good habits. And then put our numbers there, negative 6 and positive 4. There's 3 common here, so there's no 0 here, we're just factoring. So we get x minus 2, we get 3x plus 4 divided by 3, the 3's cancel. So those are my factors for this polynomial. So always do your factoring on the side. Please continue to do that. It's a good way to learn math and make less mistakes. So we get x minus 2 here, and we get 3x plus 4 is equal to 0. So this product is 0. What does that tell me? One of them has to be 0. So you get x minus 2 is 0. We get 3x plus 4 is 0, using the product theorem, since I wrote this as a product by factoring. This is a linear equation. We know how to solve linear equations. We just isolate the variables. So we get x is equal to 2. Out here we get 3x is equal to negative 4 and divide by 3. So we get negative 4/3. Once again, you can check your answers like I showed you earlier. So make sure you guys do that. Okay. Alright. The last example I'm going to do is this one, just to make sure you guys again don't do weird math. If I have 5x squared is equal to 2x. Now I have a lot of students who will do this. Like for example, let me to give you a different problem. Let's say if we have 10x squared is equal to 5x. Because you have equality, and you see if you see anything common on both sides in terms of numbers, not variables, numbers, you can divide both sides by that. For example, 5 divides 10 and 5 divides 5. So I can do this. I can divide this whole equation by 5. So I get 2x squared is equal to x, and then I can solve this, okay, like I'm going to do in a second. But you can only divide numbers on both sides, not variables. I cannot do this. I cannot divide by x. Even though there's an x here, there's an x here, I cannot do that. So please do not abuse that. You can only do that with numbers. Okay. Alright, so let's go ahead and do that. This is degree 2 equality. Move everything to one side. So we get x squared minus 2x is equal to 0. Normally a quadratic equation has 3 terms, a typical quadratic, but that's not the really requirement. The only requirement for quadratic is what? It has to be degree 2, which it is. It just doesn't have 3 terms, but I can still solve this by factoring. What's common in these 2 terms now? X, I can take that out. So I get 5x minus 2 is equal to 0. This product is 0, so that tells me what? One of them has to be 0. So x is equal to 0, or 5x minus 2 is 0. This is one solution. It's already done. Over here, this is degree 1. I know how to solve for x. You isolate the x term, and then you isolate x. That's my second solution. Now, the wrong way to do this problem, this is wrong. This is the right way that I just did, but this is the wrong way to do. I'm just pointing it out for your benefit, so you don't do that. Students would do this. They would divide both sides by x because they see an x there. So you get 5x is equal to 2, and then they divide by 5, so you get 2/5. I got one answer. What happened to my other answer? It's gone. And the other answer was 0. Because you got rid of that x, there's no way to find that answer anymore. So it's important that you don't do that. You can divide off numbers from both sides, but not variables. Okay? So that's how we solve a quadratic equation by factoring. And if you keep practicing, this will get easier. Okay? The next method for solving quadratic equation was the square root theorem. So let's take a look at that. This is the square root theorem. Now this method works anytime you have a square and a number, when you only have a square and a number. So let me go ahead and give you the theorem first, and then I'll write it down. The square root theorem states this, that if x squared is equal to a, then x is equal to plus or minus square root of a. Now we have the introduction of plus or minus, which is very important. It's one of the things students always forget to do. Basically what we are doing is, in a nutshell, okay, what I'm doing is over here I have square of some number is equal to a, where a is any number. Well, think about it. Like for example, let me prove it to you by example. If I tell you x squared is equal to 36, what would x have to be? Well, let's take a look at it. Let's just do it by trial and error and see if we can figure it out. Square of what number is 36? Well, that's easy. X is equal to 6. Is that the only answer? Remember, it's degree 2. We should get 2 answers, right? Well, x is equal to 6 and minus 6, because if you take negative 6 and you square it, negative 6 times negative 6, it's also 36. So there's actually two numbers whose square is 36, and there was 6 and negative 6. So anytime you do these problems where you have a square and a number, you always want to introduce plus or minus and then take the square root of that number. So in this case, we could have done this faster. Instead of trial and error, we could have said x is equal to plus or minus square root of 36. And we know that square root of 36 is just 6, so that is my answer. I get two answers, plus 6 and minus 6. So please do not forget to do the plus or minus when you use the square root theorem. It's a common thing that students always forget. Okay? So that is a square root theorem. Now to use this theorem, you can clearly see you need a what? A square and a number. So just remember that. So let me put that down. Note. One. To use the theorem, we need the equation, the equation needs to be in the form x squared is equal to a. Okay, if it is not in this form, then convert it to the right form before using the theorem. Okay, so this is an important note to remember, so you know exactly when to use it. Anytime you're solving a quadratic equation degree 2 equality, you have square and a number, you can use this theorem. And then don't forget the plus or minus. Basically what we're doing is, again, I do want to point out, if you have x squared is equal to a, we're introducing square roots on both sides. And because we know square root of two numbers is going to give you that a, square root of two numbers is going to give you that a, we do need to introduce a plus or minus sign on our own, just like we did here. Okay, so out here the radical and the square kind of negate each other, so you get x is equal to plus or minus square root of a. That's how we get this, just so you kind of see where it's coming from. Okay, alright, let's take a look at some examples of this theorem. So let me start with this. So let's say if I have 4x squared minus 100 is equal to 0. Now I can solve this problem by factoring, but if you recognize this form, I have a square and a number. I don't have an x variable, so basically we use this method when the b term in the quadratic equation is 0. That's when we use this method, because normally a quadratic equation has three terms, right? ax squared plus bx plus c. So if this term is not present, then we can use the square root theorem, because now I just have a square and a number, so I can use the square root theorem. So you use the square root theorem whenever the middle term is not present, which in this case it isn't. So let's use the square root theorem. So the first thing I want to do is get it in this form where you have the variable squared by itself and everything else on the other side. So I'm going to get 4x squared is equal to 100. Move the 100 over, divide both sides by 4, so you get 25. Now I can use the square root theorem that tells me what x must be plus or minus square root of 25. I take square roots on both sides in essence. So I get x is equal to plus or minus 5. That's how we use the square root theorem. Here's another example. Let's say if I have 9x squared minus 1 is equal to 0. Okay, so let's do that. Same thing, I have a square and a number. The middle term is missing in the quadratic equation. It's a quadratic equation degree 2. So let's isolate the x squared first. I get 1. I get x squared is equal to, let's make this a plus 1 just to show you what's going to happen. This will become a minus 1 then. So I get minus 1 over 9. then I get x using the square root theorem is equal to plus or minus square root of minus 1 over 9, which we know is plus or minus square root of minus 1 over square root of 9 using the properties of radicals. So that tells me what x must be what? Plus or minus square root of minus 1 is I, if you remember complex numbers, divided by 3 because square root of 9 is 3. There's the answer for that. So we can get complex answers for these problems. Alright, let's take a look at another example. So let's make it a little bit more complicated. Let's say if I have 3x minus 1 squared is equal to, plus 17 is equal to 0. Now, what kind of a problem is this? Because of the degree 2, it's a quadratic equation, because if you were to multiply this out, if you take 3x minus 1 times 3x minus 1, because of the square, you multiply twice, you'll end up with, when you multiply the first two terms, you get 9x squared, so you get a quadratic equation. So you know it's a quadratic equation. But if you just for a second just ignore this, just imagine that I don't want you to write it this way, but let's say that this was y. So really you have what? Y squared plus 17 is equal to 0. You know how to solve this, right? You move, because you have a square and a number, you move the number over and then take square roots. So we know how to do that. So that's what we're going to do here, okay? So just for now, just imagine this is one chunk. It's not something complicated like this. Just imagine it's something that's really simple. So let's write it that way. You move the number over. Let's make this a 16, so it'll work out nice. Okay, then we have a square and a number, so to get rid of the square, we're going to use the square root theorem, which gives us 3x minus 1 is equal to plus or minus square root of negative 16. We introduce the radical. When we get rid of that square, we basically take square roots on both sides. So let's take care of negative 16 on the side, which is the same thing as what? Square root of 16 times square root of minus 1. Square root of 16 is 4. Square root of minus 1 is I. So I get 3x minus 1 is equal to plus or minus 4i. Now we want to solve for x. Now it becomes a linear equation. You can see it's degree 1 now. We know how to solve that. Move the numbers on one side and isolate the variable term first. So we get 1 plus or minus 4i. And then to isolate the variable itself, you divide by 3. So we get x is equal to 1 plus or minus 4i over 3. Now this might look like a good answer, but remember what we learned when we did complex numbers. Complex numbers are always written with the real and the imaginary part separate. Right now this is one chunk. So let's break it up. So you get x is equal to 1/3 plus or minus 4/3 I. And there's your answer for that. So the problems can get complicated like that, but if you just think of this as something simple like y or z or something, where you just have one variable, you can still do it, get rid of the square. And the reason for this is, let me explain that a little bit differently, maybe that'll help some of you. I want to solve for x. X is inside the square, so my goal is first to get rid of that square, and to do that I move the number over and take square roots, and I got rid of that square. Now I can solve for x. So you can look at it that way too if you would like. Okay. Now, not all equations are going to be so nicely set up for us. Sometimes we're going to have to work at them a little bit to get them in the form that we can work with. Okay. So let's take a look at that. So let's say that if I have an equation that looks like this. If I have x plus 3 over x minus 1 is equal to 4 minus x over x minus 1. Now this does not look like a quadratic equation at all, but let's not worry about that part right now. Let's just look at the problem first. It's an equality and fractions. So my first goal should be, let's get rid of the fractions, and then we'll worry about whether it's quadratic or no. So my common denominator is what? I only have one denominator, x minus 1. So let's multiply everything by x minus 1. So you take x minus 1 times x plus x minus 1 times 3 plus x minus 1 times 3 over x minus 1 is equal to x minus 1 times 4 minus x over x minus 1. So we're multiplying everything by the common denominator, just like we've done many times before. Over here we distribute since nothing cancels, so we get x squared minus x. So that makes it quadratic, degree 2, so that's good. Out here we distribute the 3, so we get 3x minus 3, plus out here this will cancel, so we just get a 3. Okay, and on this side what will happen here? X minus 1's cancel, so we get 4 minus x. So now let's move everything to one side because it's a quadratic and it's not square and a number because you have those x terms there. So we get x squared minus x plus 3x plus x minus 3 plus 3 minus 4 is equal to 0. I'm just moving these two terms to the left. This will cancel, so will this, because one is negative, one's positive. So you get x squared plus 3x minus 4 is equal to 0. So the point I'm trying to make here with this problem is it wasn't quadratic to begin with, but we recognized that we had an equation with fractions, so our goal was to get rid of those fractions, and along the way we made it quadratic. Now we know how to solve this. If you can, so far we've only learned two methods to solve quadratic, by factoring, or if it's a square and a number, we can't use the second method since I have that middle term, but let's do it by factoring though. So to factor, we want two numbers. When we multiply, we get negative 4. And when we add, we get 3. We're using the AC method since we have three terms here. My two numbers are what? Negative 4 and 1. Negative 4 times 1 is negative 4. Positive 4 and negative 1. And positive 4 times positive 4 minus 1 is 3. And since the leading coefficient is 1, I get x plus 4. And I get x minus 1 is 0. This product is 0, so I'm going to use the product theorem. So I get x plus 4 is 0. So I get x is equal to negative 4. X minus 1 is 0, so I get x is equal to 1. So those are your answers to that problem. Okay. Now, it's not, remember what it's not always easy, it's not always good to just get the answers and be thrilled about it. You should always go back and check them. And especially whenever the variable is in the denominator. We've talked about this again and again. If in this case, since x is in the denominator, we know that if x is 1, you get 1 minus 1 is 0. So if 1 is my solution, that tells me what? 1 cannot be my solution, because if 1 is my solution, I'll get division by 0. Is 1 one of my solutions? Sure it is. So this cannot be the solution because it'll give us division by 0. So the only solution to this problem is this. So please don't forget those little subtle things that we talked about in section 2.1. If if the variable is in the denominator, you still need to go back and check your solutions. Okay. All right. Let's go ahead and continue with this. The next thing we want to do is talk about the next method, which is completing the squares. D. Now, just again to recall what this method really is trying to do. Okay, let's say if you're given a polynomial, the one we just did a minute ago, if you recall, it was x squared minus 3x plus, minus 4. It was plus 3x, was it? Yep. Okay, let's just look at this, not worry about the equation. We factored this into what? X plus 4 and x minus 1. That worked fine. But on the other hand, if I gave you this x squared plus 12x plus 36, okay, I could still factor this. I want two numbers. When I multiply, I get 36, and when I add, I get 12. They're 6 and 6. So I get x plus 6 and x plus 6. And then I can write this better. I can write it as x plus 6 squared. Now, this is what we call a completed square. It's actually a square, not completed. We're going to talk about completing in a second. Sorry about that. Getting ahead again. Not every polynomial can be written as a square, can be factored into a square is what I'm trying to tell you. This one's a special polynomial. This one isn't. Did we write this as a square? No, we did factor it, but not as a square. So what we want to achieve here in this part of the section is we want to take any given polynomial and write it as a square. That's what we want to do, any given polynomial. So our goal here is to write any polynomial, a quadratic polynomial, that means degree 2, as a square. And by that I mean something like this. Not every polynomial can be, you can do that. I just gave you 2 examples. In one case we could factor it, but we could not write it as a square. In the second case we were able to do that. So how do we go about doing that? It's actually really easy. So let's say we're given this. We're given x squared plus bx plus c. Now I want to tell you 2 things about this. Cannot be factored as a square. So that's what we want to do. So it cannot be done right now. And a is equal to 1. A has to be 1 to use completing the square. So you can clearly see that is 1. Okay? So now how do I go about doing that? Well, basically the key thing is to write something as a square is this number here. This is the magic number. If this was anything else I could not do that, but because it is 36 I can do that. So all I want to do is figure out that magic number. Obviously c is not the magic number. If it was, then I could write this as a square. So let's figure that out. So what I want to do is rewrite this as x squared plus bx. So I'm going to add that magic number. The magic number is this. It's the middle term, b divided by 2 squared plus, since we added that, we also have to subtract it. We can't just randomly add numbers into a problem, plus c. So that's what we want to do. So we add, this is your little magic thing. If you can figure this out, we can add this, and now because we added that magic number and subtracted it, these first 3 terms can be written as a square. And that's it. And these next 2 terms can be written as a number because they're just numbers. This is a number and c is a number. You just add them up, you get a number. This can be written as x plus b over 2, whatever this b over 2 is in here. And that's it. That's all you have to do is figure out what b over 2 is. The key thing is, remember, the leading coefficient has to be 1. So let's take a look at how to use completing the squares to solve a quadratic equation. So let's say if you're given a quadratic equation that looks something like this. And there are many, again, I do want to stress this, there are many different ways to do a lot of these problems, but completing the squares is one way to solve a quadratic equation. So let's say if you have x squared minus 6x plus 1 is equal to 0. This is an equation, quadratic. I cannot factor this. You can try to find the discriminant and show that it's not a perfect square. I cannot use the square root theorem because I have this middle term. So those are out of the way. So now the only other method left is completing the squares. So what I want to do is write this as a square. So I need to figure out what's my magic number. So I take x squared minus 6x plus, I take my middle term. Remember, the magic number is what? You take your b, divide that by 2 and square it. My b is what? Negative 6. So you take negative 6 over 2, square it. Since you're adding it, we also have to subtract it. Make sure you put your parentheses. Plus 1 is equal to 0. So now we added that term. So now these 3 terms, because we added that magic number here, these 3 terms can be written as a square. So I can write them as a square, and then I can add the rest. So I have a minus. What do we get? Negative 6 divided by 2 is negative 3, right? So you have negative 6 divided by 2 squared, which is negative 3 squared, which is 9. So we're really adding what here? A 9 plus 1 is equal to 0. I'm just calculating this. How about this here? This can be written as what? According to this, it is x plus b over 2. So you get x plus b over 2. That's it, not the square anymore. We just write b over 2. Just pay attention to that. There's no square here. There's a square here, but not here. So that's what we get. So this can be written as x minus 3 squared, because you have negative 6 divided by 2 is negative 3. And then these can be added to negative 8 is equal to 0. Now this problem I do know how to solve, because if you recall, we just did that a minute ago, right there, where you had something complicated, square, and a number. We use a square root theorem. We move the number over, so we get x minus 3 squared is equal to 8. Now we take square roots on both sides, so we get x minus 3 is equal to, or apply the square root theorem, plus or minus 8. Now remember, 8 can be broken down. Always simplify your answers. 8 is what? 4 times 2. Since 8 is not a perfect square, can I write it as a product of two numbers when one of them is? Sure, it's 4 times 2. What is square root of 4? 2 square root of 2. So I get x is equal to, I'm going to move the 3 over because I want to solve for x. I get 3 plus or minus 2 square root of 2. There's your answer. Okay, so that's how we use completing the squares. It's really a very slick trick. And it's very useful. You're going to see this a few other times in this class, so it's really important that you master it now, so that when you see it 2 other times later in this course, you'll be able to just use it without worrying about it, without having to relearn it. Okay, but remember little subtle things. Simplify your radicals as you're going along. Okay, all right, let's take a look at another example and do another one. Okay, so we have 3x squared minus 2x. Actually, let's do something different. Let's say if you have 2x squared plus 6x plus 7 is equal to 0. So I'm going to solve this using completing the squares. You can convince yourself that this polynomial cannot be factored, and you cannot use the square root theorem because this term is present. So that takes those two methods out of the window. I have to use completing the squares now. The only problem is to use completing the squares. I didn't point that out, but I should have in this problem. The leading coefficient has to be a 1. Is that what we have here? No, we have a 2. So my first goal would be to get rid of that 2. And because we have an equality here, I can just basically divide both sides by 2. I can do that. Remember, I cannot divide by a variable, but I can divide by a number. So I'm going to divide everything by 2. So whatever I do on the left, I do on the right. So you get 2x squared divided by 2 is just x squared. 6 divided by 2 is 3x plus 7 over 2. 0 divided by 2 is just 0. So we get that. So it's important that you see that. Always make sure that the leading coefficient is 1. Now let's go ahead and complete the squares. So I take x squared plus 3x plus, I need to add that magic number. The magic number is always the middle term. In this case, it's 3 divided by 2 squared. If it was minus 3, I would put a minus there, but in this case, it's a plus 3, so make sure you guys realize that. Since I'm adding that, I also have to subtract. Just like when we do common denominators, we multiply the bottom by something, we also have to multiply the top to negate that action. So we're doing the same thing. Plus 7 over 2 is equal to 0. So I'm just adding this magic number and I'm subtracting the same one. So now these three terms can be written as a square because that's what I added that magic number for. And then I can add these on the side. So let's do that here. Let's do this. I'll come back and finish the middle. 3 squared and 2 squared, so you get negative 9 over 4 plus 7 over 2 is equal to 0. And over here we get x plus b over 2, so which is 3 over 2. That's what we get. It's always b over 2, not the square, just b over 2, which is exactly what we have in here. So now I can rewrite this as x plus 3 over 2 squared, and then I can add these numbers up. I need a common denominator, so always do that on the side. Don't ever do it in the problem. I have my negative 9/4 plus 7/2. So I get common denominator is 4 So I get plus 14 because you'll multiply this by 2 and this by 2. So we end up with 5 over 4. So we get plus 5/4 is equal to 0. Okay. Now what does this problem look like? Well, you have a square and a number. Well, I know how to do that. Use the square root theorem, move the number over, and then we take the square roots on both sides. If you recall, we did that earlier today. So let's take the square root. So we get x plus 3 over 2 is equal to, we introduce plus or minus 5 over 4. Once again, go on the side and simplify this radical. What is minus 5 over 4? Square root of minus 5. It's the square root of minus 5 over square root of 4. Square root of minus 5 is just square root of 5 times square root of minus 1 over 2, because square root of 4 is 2. 5 cannot be broken down, it's a prime number, so it's square root of 5i over 2. So let's do that. So we get x plus 3 over 2 is equal to plus or minus square root of 5i over 2. Now we want to solve for x, so let's move this to the opposite side. X is equal to minus 3 over 2 plus or minus square root of 5 over 2i. And there's your answer. Okay. Now, I do want to point out that whenever we have imaginary solutions, we always want to write the real and the imaginary part separate, which is already nicely separated for us, so we don't need to do any extra work. Okay. And so that's how you do completing the squares. I hope you understand this. Just practice a few problems, look at the ones that are worked out in the lecture notes, and you should be able to do this. Okay. The key things to remember, again, I do want to stress leading coefficient has to be a 1. If it's not, let's make it a 1. Okay, and we will see this method 2 other times in this class later, so please, master it now so you don't have to master it later, relearn it later. Let's do the last method to solve a quadratic equation, which is using the quadratic formula. Out of all the methods, this is the easiest one. If you're given a quadratic equation like this, I can find the solutions very easily. My solution is x, what I'm solving for, is minus b plus or minus square root of b squared minus 4ac over 2a. There's your quadratic formula. Always works. It's always something you should always know, just in case none of the other methods work. This will always work. Okay, the completing the squares also always works, but this was easier. Okay, now just so you know, this quadratic formula that we are looking at was derived from completing the squares. That's why completing the squares is so important. Okay, alright, let's take a look at an example. I'm just going to do one example. But before I do that, just something to note. This thing, we've seen this before, correct? So let's just point it out. Note that b squared minus 4ac1 is the discriminant. We've talked about that before, so let's just call it d, is b squared minus 4ac. That's where that came from earlier. There are a couple things to note about this. If d, the discriminant here, is greater than 0, that means it's positive. Okay, then the quadratic equation has two distinct real solutions. It's just something you can tell by just looking at this value. You can tell what kind of solutions you're going to have. Two distinct real, that means they're not complex, they're not imaginary. Distinct means they're two different solutions. Okay, and that makes sense because if this is a number, let's say this was 5, because of the plus or minus, you're going to get two real solutions because it's positive, correct? So that's what it really boils down to. On the other hand, if d is equal to 0, Okay, then the quadratic equation has two real repeating solutions. So what that basically means is, if this is 0, if the discriminant is 0, that means this thing here, remember it was plus or minus square root of b squared minus 4ac. If this is 0, this whole thing is gone. This whole thing is 0, so it's no longer there. That means the plus or minus are gone. So I just get one value for x. But because it's degree 2, we know we should have 2, right? So that means that tells me that the other value must be exactly the same, because technically you have plus or minus 0 is what you have. So when you take b plus 0, you get one solution, and you get minus b minus 0, you get the second solution. So you still get two solutions, but they happen to be exactly the same. And then the last case is if d is less than 0, that means it's negative, then the quadratic equation has two complex solutions. So the discriminant tells us a lot. Not only does it tell us whether the quadratic polynomial can be factored, but it also tells us what type of solutions you would have if it was an equation. So let's take a look at an example. Let's do the one we just did. I'm just going to do one example because they're pretty much the same. We have 2x squared plus 6x plus 7 is equal to 0. We just did this example a minute ago using completing the square, so let's do the same problem using quadratic equation. So a is equal to 2, b is equal to 6, c is equal to 7. I do want to point out, if any of these numbers are negative, like for example, let's say this was a minus 7, then make sure you guys put parentheses. It's always a good habit to get into doing that. Those little subtle things that you do will stick with you and make you better mathematicians. Alright, so the formula, also always write the formula down every time you use it, even if you know it. I always do that in spite of so many years of working with the quadratic formula. I still write it down every single time I use it. Okay, so here's my formula. So we get x is equal to minus 6 plus or minus square root of 6 squared. Oops, before I do that, we need to calculate the discriminant. This is just for your benefit to show you what is my discriminant. B squared minus 4ac. I just want to see what type of solutions I'm going to end up with. So I get 6 squared minus 4 times 2 times 7. 6 squared is 36 minus 4 times 2 is 8. 8 times 7 is 56. So we end up with negative 20. Since the discriminant is negative, that tells me I'm going to get complex solutions, which is correct because that's the solutions we had before. Okay, so we already know that, but it's a good thing to do for two reasons. We can know exactly what type of solutions we're going to get, and now I don't need to calculate this anymore because I already did that here. So I get x is equal to negative 6 plus or minus square root of negative 20 over 2 times 2. I always do the discriminant on the side, so then I don't have to do it within the radical anymore. I can just plug it in, and that tells me what solutions I have. So let's figure this out. Let's do square root of 20, negative 20. That's the same thing as square root of 20 times square root of minus 1. Now 20 is not a perfect square, so ask yourself, can I write it as a product of two numbers where one of them is? It's what, 4 times 5i here. And square root of 4 is 2 square root of 5. So that's what we get. So let's do that. We get x is equal to negative 6 plus or minus 2 square root of 5i divided by 4. And at this stage you might be happy to be done, but you're not. Remember, we have complex solutions, so we have to separate the real and the imaginary part. So you get negative 6 over 4 plus or minus 2 square root of 5 over 4i. And then we can reduce also. Don't forget to reduce. Negative 3 over 2 plus or minus, this cancels, becomes a 2, so it gets 5 over 2i. And there's your answer. That's exactly the same answer we had here. You can see that right there. Okay, so when you're doing the quadratic equation, I'm not going to do any more examples. All you have to do is plug it into this formula, write it down every single time you use it to help you memorize. Just plug it in, do it step by step, and you should get the answer. When you use this formula, just do the discriminant on the side so you know what type of solutions to expect. It's always a good habit because you're going to have to do it here anyway. So, okay. I hope this section makes sense. It's a very important section because we work with quadratic equations a lot, so it's important that you master them. Do your homework. That'll help you master the concepts.